Greetings, Caymans. Mr. Eicher here at Classical Academy. This is my room that I'm sitting in. Oh, happy day to be back to the classroom. Now we just have to get you back to the classroom one of these days. We're going to be talking about a lesson on common logarithms today, so let's get started. A common logarithm, it's common because it's the most common, so common logarithm, and it's base 10. Base 10 common logarithm, you'll see here a little 10 written there. But I'm here to tell you that if you ever see a logarithm that doesn't have a base, notice, what? Where's the base? It's understood mathematically, it's known mathematically to be a common logarithm of base 10. So log base 10 is really written like this, just log. The graph of a common logarithm is the inverse of 10, a base 10 to the x. So if we were graphing base 10 to the x, we'll just do a couple points here. If we plug 0 in for x, oops, sorry, just lost my table. If we plug 0 in for x, we would get 10 to the 0 is defined as 1. Then if we plug 1 in for x, we would get a 10. So we can graph 0, 1, 1, 10, and suddenly we've run out of space, but that's okay. Our exponential function, 10 to the x, has quite the large base, so it grows very quickly. So this is y equals 10 to the x. The inverse is going to be a reflection over the y equals x line, slope of 1, y-intercept of 0. This is y equals x line. And the inverse, y equals log base 10x, we're just going to flip-flop these coordinates x and y. So we would have 1, 0 and 10, 1. So the graph of log base 10 to the log base 10x would look like that. So this is y equals log base 10x, which really we could write as y equals log x. Don't have to write the 10 there because it's understood mathematically to be a 10 if there's no number there. The calculator, actually, if you take your calculators out, calculator has a log button. It depends what your calculator looks like, but you can ask your teacher when you get to class if you can't find it. But it says log, not LOL, but log, log. So you just hit log and then 12. Some scientific calculators, you have to hit 12 and then log, but most calculators you hit the log first. So make sure you can do that. We're rounding to 4 decimal places, the nearest 10,000th. So that would be 1.079 and then a 2. It was a 1/8, but the 8 rounds the 1 up to a 2. And what this is telling us is if I had a base of 10 and I wanted to know what exponent will get me to 12, that exponent is 1.0792. You can even try that on your calculator. If you did 10 raised to the 1.0792, you would get roughly 12 due to rounding. And then just one more try, log 2.3. That's basically saying if I had 10 as a base to the x, and I got an answer of 2.3, what exponent would I need? Well, it's going to have to be less than 1, because 2.3 is less than 10. And I get this answer rounded to 4 decimal places, 0.3617. And then you have one in your own here as a try this problem. You can do that now if you want to save time later. One application of common logarithms is in chemistry. The pH level of a substance is given by pH equals negative log, hey, there it is, log base 10, of H plus, where H plus is the hydrogen ion concentration in moles per liter. So we're asked here to find the pH of each substance given its concentration of hydrogen ions. For vinegar, vinegar has 6.3 times 10 to the negative third moles per liter for its concentration. So using this formula, the pH is going to equal negative log and then 6.3 times 10 to the negative third. And what is that roughly? Encourage you to pause the video. Make sure you can type that correctly in your calculator. It'd be a shame to miss one of these because it's really just plugging numbers in your calculator. Negative log 6.3 times 10 raised to the negative 3. And sadly, I got the wrong answer because I put 0, 1 rather than 10. 10 to the negative 3. So I get the answer of 2.2 is the pH on a pH scale. It doesn't say what to round to here, so I'll just round to 1 decimal place. And then number 5 is for you to try out as a try this. So that's an application of a common logarithm. There are other applications like the Richter scale and earthquakes, also decibel level, light intensity. There's a lot of natural phenomena that can be modeled with a logarithmic function. The rest of the lesson, we're going to be looking at solving exponential equations. And to solve an exponential equation, these are called exponential equations because the exponent is a variable. Notice all these variables up there as exponents. That's different than if it had said something like this. This is not exponential because the variable is not in the exponent. So how do you solve exponential equations? Well, that's actually why logarithms were developed in the first place back, I don't know, maybe 400 years ago, is to be able to solve exponential equations. The directions don't say at all that we have to worry about extraneous solutions. We only really have to worry about extraneous solutions when we're solving logarithmic equations like we did 1 or 2 lessons ago. So to solve number 6, we're going to isolate the exponential. The exponential here is already isolated. It's just a base and an exponent. There's nothing in front of the 5 or after the x or anything like that. We're going to log both sides to bring the power down in front of the log. There's the power rule that you learned in the last lesson, 6.3, that logarithms have the special capability of if it's log of something with an exponent, you can bring the exponent down, the power down out in front, and then isolate the variable and solve. So we'll start off with number 6. We have, it's already isolated. We're going to log both sides. So log 5 to the x equals log 52. And remember log 52, we have a calculator, so that's just some number. And then log 5 to the x, the second step is this exponent of x we can bring out in front with our power rule. So we can write it as x times log of 5 equals log of 52. And now that we have the variable out in front, we can isolate that variable and solve. So to isolate this variable, we're going to divide both sides by log 5. Remember, log 5 is just some number the calculator can give us. So x equals log 52 over log. And when you type that in your calculator, I'd encourage you to make sure that you use parentheses right here. Or a good idea is right when you type that numerator, hit enter on your calculator to get the number. So if I did that, I do log 52, enter. I get 1.7 blah, blah, blah. And then hit divided by, and that should use your previous answer, log 5. So just to check, make sure you can do it on your calculator, but we would get 2.4, rounding to 4 decimal places, 550. So that's our answer. What that's telling us is if we did 5 raised to the 2.455, what does that give us? 5 raised to the 2.455. That gave me 51.996. And notice that's basically 52. We didn't get exactly 52 because of rounding. I rounded this answer. But that's all that the logarithm's telling us. What x do I need to plug in there to get 52 as an answer with a base of 5? All right, let's look at number 7. I'd encourage you pause the video, see if you can do a step or two on number 7, and then replay the video and you can check your answer. That's a good way to learn math. See if you can do a step or two on your own and then check it with what the teacher does. So the first step, the exponential, this is already isolated. There's nothing out here, there's nothing out here. So we can jump right to our second step, which is log both sides. Log 4 raised to the 3p equals log 10. And then once we have that, we use a logarithm because our power here, we can bring down out in front 3p times log 4 equals log 10. And now we isolate the variable p. So we're solving for p here. We've got to divide both sides by log 4. And I might as well divide by 3 while I'm here. Just be careful if you're going to type that all at once in your calculator. You'll want to use parentheses here. Maybe I'll do it in a different color. You'll want to use parentheses here if you want to try to type it all at once. So we would have log 10. Log 10 is 1. That's because your base is 10, and log base of the same base is 1. Divided by parentheses 3 times log 4. So you should get this answer. So definitely double check here. I don't want you missing it just because you typed it wrong in your calculator. 0.5537 is the answer. So that tells us, just to do a little check, that tells us if you do 4 raised to the 3 times 0.5537, you should get, let's see, 4 raised to the 3 times 0.5537, you should get 10. And I basically got 10. This decimal here is just due to rounding our answer there. And then number 8 is your first try. So if you'd like to try that right now, and then you'll be able to plug your answer into Schoology later. Let's try number 9, and then we'll do some of the others in a follow-up video. But number 9, the base and exponent, these are isolated already. There's nothing out in front or behind here. So the first step, we're going to log both sides. Some students who understand what the second step is going to be kind of do 2 steps at once, and that's fine. There we go, log both sides. And then the second step is what? Are you thinking about it? What you're going to do? You thinking about that? This little exponent right there, you know where that's going to go? X cubed out in front, that's the power property, times log of 2 equals log of 64. And then we need to isolate the x, so we're trying to solve for this x guy right there. So we're going to divide both sides by log 2, like so. So that gets us to this point, x cubed equals, let's type that in my calculator, log 64, L-O-G, log 64, enter, and then divide by log 2. Oh, that's nice, I get a 6. A whole number 6. And then to solve for x, we would do a cubed root of both sides, cubed root of 6. There's no plus or minus here because it's an odd root, so we only have the principal root. So the cubed root, let's see, cubed root button, cubed root of 6. If you can't find the cubed root button, remember you could use a rational exponent, 6 raised to the 1/3, and that'll do the trick for you too. But you should get 1.8171 as the answer for x. So that means if we did 2, just a little quick check, 2 raised to the 1.8171 and then cube that, let's see, we have 2 raised to the 1.8171 and then that's cubed. See if my calculator can handle that. I get 63.991. And again, basically 64, just an issue of difference in rounding. Thanks for watching this video. I'll see you next time when we do a couple more practice problems. Bye.